to Discovering Geometry with Mrs. Berry. This is lesson. We're talking more about area. Today we're going to talk about the area of triangles, trapezoids, and kites. Our first investigation is to find the area formula for triangles. You're going to need cardstock or cardboard, and you're going to want to cut out a pair of congruent triangles. Label their corresponding parts as shown in the picture. Arrange the two triangles to form a figure for which you already have an area formula. So what is the area of one of the triangles? We'll make a conjecture. Let's look at how we could do this. Here's our triangle. If we cut a second triangle and arrange them, we could arrange them into a parallelogram. And we already have the formula for a parallelogram. It's just base times height. So for one triangle, we will have half of one of the base times the height. The triangle area conjecture. The area of a triangle is given by the formula A equals 1/2 BH, where A is the area, B is the length of the base, and H is the height of the triangle. Now let's look at an area formula for trapezoids. Again, we'll need cardstock or cardboard. You want to construct any trapezoid and an altitude that's perpendicular to its bases. Label the trapezoid. Now cut out the trapezoid and a second copy of the trapezoid. Arrange the two to form a figure for which you already have an area formula. What type of polygon is this? What is its area? First, we have our first trapezoid. We have a second trapezoid that we're going to cut out, and we're going to be able to line it up right next to the first one. When we do this, we can see that we have a parallelogram. But now, the length of the base is both base 1 and base 2 of our original trapezoid. The height is still the height. So if we were to look at this entire picture, this entire parallelogram, we would have the height times the base being base 1 and base 2 of the trapezoid. However, we only want to take one of these, so we do 1/2 of the height and the bases added together. It could also be written as the height times the bases added together over 2. This is just rearranging where the fraction comes in. And some people like to look at this last one because it looks like the average of the bases right here. So if we were to average the two bases of the trapezoid and multiply it by the height, that would be the area. So how can we write that area formula? Area equals 1/2 base 1 plus base 2 times the height, or you could write it as the height times the bases added together over 2, where A is the area, B1 and B2 are the length of the two bases of a trapezoid, and H is the height. The last one, what is your investigation to find the area formula for a kite? Try using the same steps that we did for the others. Cut out a kite out of cardboard or cardstock paper. Maybe cut a second one. You may need to cut them apart a little bit to arrange, or just think of how you could divide one into a different polygon that we already have the area formula for. Here's how I thought about the area formula for a kite. I thought about how I could divide this kite into two triangles, each with the base that is purple line. The height of these two triangles would be red for one of the triangles and the green line for the second triangle. So if I cut them apart, here's what I have. I already know the formula for the area of a triangle. It's 1/2 base times height. So if I want these kites together, the 1/2 is the same for both. The base is the same for both, but I have a red height and I have a green height. I'm using a subscript on the H just to denote that they're different. The bases are the same. If I'm adding these together for the area, I could factor out the 1/2 and the base and say that it's 1/2 times base times the red height plus the green height. I could then say it was maybe 1/2 the base times the total height. At this point, I might want to go back and look at the kite itself. The purple line isn't really the base. It was the base of the triangles when I cut it apart, but it's really a diagonal of the kite. So it's one of the diagonals, and then the total height, that red plus that green line, is a second diagonal of the kite. Now I have my area formula as 1/2 of the first diagonal, the purple line in our case, and the second diagonal, the red and the green one added together. So the kite area conjecture is that the area of a kite is given by the formula A equals 1/2 d1 times d2, where A is the area, d1 and d2 are diagonals of the kite. And that is an area formula for the kite. Let's do an example. How do we solve for x and y in this picture? I'm going to start by looking at areas. If I take the base of this triangle as 15, the area of the triangle is 1/2 15. The height of the triangle to the 15 would be the x. How else could I take the area of this triangle? Well, I can use a different base. 1/2, let's use y for the base. Y is my base, so what line is perpendicular to y? The height, if the base was y, the height of the triangle would be 5. So again, the height is the altitude of the triangle, and altitude can be outside of the triangle. So in this case, perpendicular to y is that 5. What if I use the 6-foot side of the triangle as our base? If I use the 6-foot side of the triangle as my base, then I'm going to go up here and find that the perpendicular line is the 9-foot line. So that would be the height. Here I finally have one that I can get an answer for. 1/2 times 6 is 3. 3 times 9 is 27. Now I'm going to move along and say that 1/2 y times 5 is also equal to 27. And 1/2 15 times x is also equal to 27, because that blue triangle is the same for all of them. So to solve for x, I'm going to start up here. I'm going to take it down. I have 1/2 times 15 times x is equal to 27. I'm going to start by multiplying by 2 on both sides to get rid of that 1/2. So 27 times 2 is 54. And that's equal to 15 times x. I'm now going to divide 54 by 15 and find that x is 3.6. I'm going to label it with my units, which is feet. Now I'm going to take the last one. 1/2 y times 5 is equal to 27. If I multiply both sides by 2, I have 5 times y is equal to 54. I'm going to divide by 5. 54 divided by 5 is 10.8. And then we're going to add our units of feet. So now we have an answer for x and an answer for y.